Hello everyone and welcome back to Dad's Shed. The video today concerns the milling machine, but this is not my normal introduction because I filmed that a few days ago along with some other bits and pieces, but after that I found that my primary camera had been played with by the children and the video was not usable. The secondary camera was working fine and that shows the components, but the primary camera, yeah. The other thing is that since I've started the video and editing the video, I have checked online and found that a warning I am giving in this may not now be relevant, but I'll leave it in there just in case, and that is regarding the scale lengths. I noticed today they've now said on the website that you order the scale length appropriate to your travel, which is not what it used to be, and they will then add on the 140mm. So you don't order the length of the scale you want, you order by the travel of the slide, which is good news because it shows that myself and a number of other people were correct, that they were actually specifying it slightly differently, I think is the best term. You may notice some shiny bits, and that's what this video is all about, and I'll leave my other self from 4 days ago to explain to you exactly what it is. I've been busy over the last couple of days with the milling machine. Now I will point this out to you. This has been on the milling machine for the last 20 odd years. I think I bought it in about 1997 or 1998. It's an Ortec digital readout and it's been okay, but it doesn't have any of the real facilities on it apart from measuring, zeroing and doing an inch on metric. The other little issue is that the scales that came with it were not quite the right length. They were all slightly too small, especially as this mill actually has the 4-inch extension on the base. So I ended up using the height reader for the y-axis, the y-axis reader for the x-axis, and I didn't use the z-axis at all. So I couldn't measure accurately height up and down. Not a major issue. It's got reasonably accurate dials on it, so you can get it to within a thou or two. But it is a bit of a pain. And I bought off eBay a digital readout system for the mill, which seems to be doing quite nicely. So I thought it's time for an upgrade. So that has been taken off. I'm going to see if I can use this on the shaper, but that's going to be something in the future. So let's put that out of the way for a moment. And introduce you to my new digital readout. It's a Kexin, which is one of the generic Chinese make, 3-axis, and it has all the usual bells and whistles that you get with a digital readout now. Not particularly expensive. As I say, it will be better than what I've had, and it will give me all 3 axes. And with that, I have the 3 scales. And the kit also comes with fixings which include some alloy 3mm angles, and screws and washers. It also comes with, he says, you can get down here, a clamp to go on to wherever, and a short arm. Now I decided not to use that because if I can get it to move round, which I can't quite, I've built an articulated arm to take my previous readout. So all I've done is drill through the 6mm hole, 10mm, and I've fitted this to that, so I've got a lot more movement and I can articulate it and swing it round. So what do you need to fit this? Well, that is the biggest tool, and it's got a 4.2mm drill in it at the moment, which you need for the 5mm Allen bolts that fit the majority of the parts on this machine. And you get a good selection of bolts with it. Luckily I also have my own, although most of my stuff in here is Imperial. I do tend to keep a selection of metric, and I've got a selection of metric Allen head bolts that I bought, and I've been shortening some of them to give me the length I want for the way I'm applying the scales and everything else. So 4.2mm drill, 5mm taps, and the only other thing that I've used in the shed is the pillar drill for drilling a lot of the holes, the belt sander I have, and an angle grinder. Oh sorry, I nearly forgot the bandsaw. So let's move that out of the way and put that over here. I'll move the most important tool in the workshop. And you get plastic bags like that with washers, screws, end caps for the covers. Although I must admit, finding a way to fit them is going to be a challenge because there isn't a lot of space around them to just clip those on. Other things are going to get in the way. So they will go on like that, but with modification to suit the application they're being used in. So that one, I haven't taken that off because I couldn't be bothered having taken it off the machine. As you will see, the alloy pieces that you get, the angles, have all been modified somewhat. That's the least modified. So you've got an unequal angle, short side, long side. They actually fit over there, so you can use them that way. You've also got 4mm screws in there if you're using that side to mount them. But there is a small problem, and I picked up that it's not just me when I looked at another YouTube channel, because these are not the length they say they are. And I thought it was just me, but it's not. And in the next little bit of video I'll mention it again. But as a warning to anyone, if you are buying one of these off of eBay, it will say to you, measure your travel, add 140mm to it, and that is the size of scale you want. And to be honest, that sounds sensible, because if you take that, which is 80mm, and that's 20, and that's 20, so that's another 40. That's 120 millimeters. So if you add the length of the reader head and the two ends, you've got 120 mil. So 20 mil, just under an inch, or 3/4 of an inch, would give you a little bit of wriggle room on that. Now, these are marked up. This is a 600 millimeter scale. This one is a 700 millimeter scale. This is a 300 millimeter scale. But they're not, because they add 140 millimeters onto it as well. So your 300 millimeter scale, when it comes in, is 440 millimeters. So instead of being a foot long, it's nearly 18 inches. And I thought it was just me. I thought, but no, I've seen a couple of videos where this is a common problem. So bear in mind that what you get is going to be 140 millimeters more than you actually need. That can be an issue. Now these are glass scales, and there's a lot of stuff out there that says you've got a glass scale, it's the wrong size, you're stuck with it. That's not actually true. They can be cut. Before I committed to this, I actually went onto YouTube and I found some videos of people cutting glass scales. I will show you in a minute how I did it, but I actually tried two ways. One is using a hacksaw and one is using a bandsaw, both of which I've seen on YouTube. I would not advise the bandsaw method. It does work, but it does potentially give you problems. Hacksaw is much better. The glass scale will not cut, it will break, but there is a way around that, and that is by packing in here with the packing that this comes in. If you cut it up and push it down the side so it supports the glass scale, it will break at the point where you're cutting, or close to. You get a rough edge, you don't really want that, so I used a small diamond wheel on a Dremel and just tied it up the end, and it needs to be moved back about 10 millimeters from the end, because these end caps have an insert which goes into the inside of the extrusion. So you need 10 mil clearance to get that in there. But there again, you're probably not coming right up to the end of the travel anyway. So that's not a big issue. So, a little bit of work. These have been shaped so they take up as little room as possible. That just fits over here. That one goes up the side. And to fit that one, there are two angle brackets. They were 50 by 50 angle. I've cut them down to the size I want. This bit, as you can see here, was put in the shaper because the milling machine's out of use, and that was just taken down flat. It's black angle, so it's not a great surface, but I don't need it to be. As long as it's giving me a square face, that's all I really care about. These will be painted when I can find the paint that matches the mill. At the moment, they're just going to be natural finish. I've rounded the edges off so that if I'm reaching over, I'm not going to take a lump out of my arm. And again, that's the belt sander. And that is the piece that goes up inside. That, and I'll show you where that goes in a minute, has been modified so that I can still use the lock on the vertical travel. Some spacers to space across from here to the plate. So that will sit on there. That sits there like that, and that goes through there and is just screwed through. All of the mounting holes, with one exception, have got clearance around them, so that although they're 5mm, the holes are drilled out to about 5.6. That gives a little bit of wriggle room on the mounts. I've been careful setting them up before I drilled and tapped for the mounting bolts, but it never hurts to have a little bit of room to move things and just get things set up. You have got movement on these, and they will go in and out. You can see they're slotted there, but not a lot. That's more than enough to get that way, but I like to have movement in two planes so that I can make sure it all lines up. And realistically, that is all there is to it. It's taken me a couple of days in here with not a lot of time to get these done. I say modifying some of these to fit, because there's not the space you'd like to have. There are things get in the way. To fit it, 4mm Allen keys, and that basically is it. 17mm on the bottom of the angle of the bracket for this, and that will just sit straight on the top there. So that's where we are at the moment. I'll show you where I've modified the mill, and all the modifications are some 4mm tapped holes, with one exception, and that is for the Y travel, where I actually have a screw in there which is 2BA. Now why, you might ask, because I certainly did, and the reason is I did not have a countersunk 4mm screw, and 4BA is effectively 4mm. I had a few of those, so I've used 4BA for one of the holes just because I happen to have the screw that fitted. So I'll show you how it goes on. I've just taken the end cover off, which fits in like so, and there's 4 2mm screws hold that, drilled into the ends here. So what I'm going to do is, following some of the guidance that's been online, I'm going to take the reed head off, and that will just slide out. I'll take these 4 yellow pieces of sealant out, and then I'm cutting it with a hacksaw. Apparently that works, and there is video evidence to show it. I know video evidence doesn't mean it's true, but it does seem to show that you can do this. So I've marked up where I need to cut. I've just unscrewed the end cover, and I'm going to lift this up, turn it around. I'm very careful with this, that I'm only gripping it across the stronger sides. Now I'm going to pull this, take that away. I don't need that until I'm fitting it. I'll move that out of the way, and I'll take the reed head off. I'm looking very carefully at how it sits in here. Okay, that sits over there, that sits over there, and that's sprung on. Okay, that's looking quite nice. That sits in there, holds it in place, and it gives a spring loading. Excellent. So I know how that goes back in, I hope. I'm doing this first with the Z-axis, the vertical, simply because I don't really need that. I'm currently working without it, so if I foul this up horribly, I haven't lost a great deal. Obviously I'm hoping not to foul it up horribly. Now I'll just unscrew this end, Okay, so that's the end block off that end, and hopefully these will now, yeah, there we go, one at a time. That's going to be fun getting them back in though. Might put a little bit of silicone on there just to help it slide and put them back in. Yeah, that's nice and easy. Good. That's now clean and clear. Just inside there is the glass scale. So I've got to cut it there. So what I'm going to do, as you can see, I've just put a line on the side. So I've got to cut it there. One of the little tips that was given on one of them, where he actually cut this on a bandsaw, is to use some of the rubber packing that it comes with and just pack it in either side of the glass scale. Stops the glass scale moving around while you're cutting through it. And apparently you can just cut through it with a hacksaw. So I'm going to make use of this. I always like to make use of helpful tips wherever they come from. I have no problem with stealing other people's ideas if it's sensible. So I'm going to cut this up, trying to miss my finger with the Stanley knife. I always find that's a good move, trying to miss your finger with Stanley knives. Don't know why. And then see if I can pack some of this down in here. That's not going to work. So let's try and find something a little bit thinner, and then we'll get this set up ready to have a go at cutting it. So what I've done, I've just put in there some of this packing which I've cut down. The hope here is that as I cut through, the packing will hold onto the glass scale, prevent vibration from the hacksaw going into it, and that should then stop any damage to the glass scale when I'm cutting through it. That's the theory. Let's see what happens in practice, shall we? That seems to have cut the scale. Now if I get a file, right. Let's have a put that back in there. Got here the spacer, which is plastic, which I can push in there, and that will help me pull that out. And the glass scale is there. Okay. So in theory, that should be done. Yeah, because that needs to go out the way, because that won't actually go in there with it in that position. That needs to sit underneath. So the option is I can either file a bit out of there, or I'll just get the diamond wheel and see if I can push that, cut it off a little bit further back inside. I think the diamond wheel looks like the better option. Well, having attached it with my Dremel, I couldn't film it because everything was in the way. I now seem to have got that down, so I'm just putting these back in. I'll just use a scalpel to trim them off to length. That's the first one. And just feed them literally in at that end. Trim that off. Just have a quick double check. And that will fit in, that fits quite nicely there. Okay, so I'll get the other end on, which was actually this end. So I'll screw that on the other end, and then I'll put the reed head back in, and then put this one back on, and then we'll take it over and plug it into the console to see if it works. Right, well that reed head has now gone in, and that's going up and down quite nicely. I'll put the spacer back in there. That spaces it off the runners. I'm going to double check on one of the other ones. I'm going to take the end off and have a quick look inside. I do need to modify the length of that as well. Okay, this is the recently shortened scale, and as you can see, as I play around with it, it's going up, it's going down, it's hitting the 0 point, it's now coming to a positive side, so that's doing what I want it to. Yeah. The only issue to bear in mind so far is that you need to then, once you've cut the whole thing, you need to shorten the glass scale by about 10 mil to allow the end cap to fit on, because it actually fits into the extrusion, and that's where the glass scale is sitting. So you do need to actually be able to cut it back a little bit. So I've used a diamond wheel on my Dremel, and that seems to have done the job, but you do need to make sure you're actually supporting the back of the glass scale while you're cutting it, otherwise it's going to snap. But as long as it only snaps locally, that doesn't actually make any difference, because you're not using the last millimetre or two of the scale. So now I know I can do that, I can work out the measurements for the rest of the milling machine and cut those scales to length. So that's the vertical scale done. I now need to get the horizontal scale sorted. That gives a little bit of movement on there so I can get it set up properly. The next thing is to get hold of this section. Just get those into locate, not tightening them up at all, just literally locating them in there. Okay, that's in and loose. What I'm going to do now, I can't raise this up very much because I've got the other unit in the way. But let's see what we can do with this. Yeah, there we go. Okay, and one screw in there, it's just in there finger tight. There's another screw in there, also in finger tight. Spacer in there, and then locate that into the threaded hole, and that will hold that there. Again, in there, spacer, locate it in the threaded hole. I have had to run the tap through some of these holes to clean the threads up, because I found that they really did not want to sort themselves out properly. Those spacers then give me a millimetre gap from the reed head down to the scale itself. Loosen those off because these haven't been done up, so just tighten those up. That's done that. That's done that. Then that should go up and down quite nicely. That side is set, but what I will do is I will run a dial indicator up and down just to make sure that it's not at the wrong angles. So that's that one. The next one, which is probably the easiest one of the lot, is the y-axis. That's that one. goes there. Go up to the other end. Screw goes in. So it gets interesting is getting the washer over the screw and then finding its way into the hole. It's got the tapped hole. There we go. Just under. Okay, that's that and that. That needs to just move along a shade. And 2 short screws in there. I did my usual and cheated. I like cheating, it makes life so much easier. And I drilled the holes in, I worked out where I needed the holes to be. I drilled the holes in the bracket, fitted this all up, and then drilled through, and I drilled the holes at tapping size in the bracket, and then drilled through into here to mark it, moved it out of the way, then drilled through tapping size, before tapping it, and then I drill clearance size into the bracket so I know that the holes line up with the holes in the bracket. So that's the Z and the Y axis. This one is a little more interesting because it's in a most awkward position, in that the only place I could put it sensibly is underneath. And the bit I'm doing is under here, and what I'll do is I'll take some shots and fill in. As you can see here, I've got the plate, it's in position on the reed head, and that is, I'm using the bolts on there to hold it up against the base. And now if I can find some light, so that I can see what I'm doing. Let's see if I can get these last 2 screws in. That's that one. Does make a big difference when you can actually see what you're doing. Unfortunately, that's not always the case. And obviously this mill, well, that's a very late Tom Senior, hence the Denford house colours, is still quite an old machine and not really designed for things like digital readouts, because there weren't any when this was made. So that's that, and that is that. So this is now on. As you can see, I've rounded off the edges here. That's done up. And the whole thing is now ready, with one exception. And that is this little piece here. That is the locking bolt for the vertical slide, which I'll need to remake because it's actually far too long. And there isn't enough clearance to get it in there underneath the reed head, I don't think. I'm going to give it a try, but I don't think there's enough room. So I'll bring you back in a couple of minutes when I've got this ready to test. Okay, let's see where we are. I've connected the last of the bits up. I've lined everything up as carefully as I can at the moment. I just want to check that it's all doing what it should. So let's come over here, hit the magic button. It's gone through its checks. Okay. So let's just hit 0, 0 and 0. Let's try the y-axis. Which for some reason I've locked off. I was checking I could actually still get to this, and I'd actually put it in drive so it wouldn't move manually. So there's your y-axis moving. That's in inches, millimeters. That's good. X-axis, forwards, backwards. And the one I've never been able to do before, the Z-axis. Yay! So that's all working. The only problem I've really got now is making a new bolt for that, and trying to work out if I can get covers, certainly on the y-axis scale. I've got the covers that are a bit too big. I can cut those down. The big problem is not getting in the way of everything down here. So it can only really have a cover that comes out and drops down an inch. That would be better than nothing. So I'll have a play with that in a little while and see if I can actually get that cover on. Because as you may notice, or may not on here, is part of a gear. I've roughed it out with the angle cutter I've got there, and I've now got a nice new old milling cutter in. It arrived quicker than I expected, so I can crack on with that. And I need to move this across 50 thou to get it lined up. I've now got a scale that will enable me to do that, hopefully with some degree of regularity and accuracy. But also then I've now got the Z scale, which will enable me to bring up 215 thou to cut to depth, which I've never had that before, apart from the fairly nice scales that are on the mill, but they're sort of 1 thou increments, and if you want to go slightly less than that, it's a bit of a pain, and you then have to convert it if you're doing metric. So this will hopefully make my life a lot easier. Okay, problems. Well, I have to say they were fairly minor, and they concerned the scales. Now, hopefully you can see I've used some of the packing in there when I cut the scales to support the glass and that worked well on 2 of them. The one it didn't work quite so well on was the short scale, where I cut that off in the bandsaw. And it could be I've got the wrong type of blade in it, but that did break about 1/4 to 1/2 an inch further down than I wanted it to, and it snapped. But the 2 that I did with a hacksaw were not a problem at all. The main problem I had with them was taking the end caps off. And as you can probably see here, it went and proved the feeling I always have about Chinese screws. The heads were awful. They're Phillips, allegedly, but they're not quite Phillips. They're not posi drive, and the heads seem to be made of a sort of a hardened cheese. And 4 of the screws, as you can see there, I had to drill the heads out because they were rounded off by the screwdriver. And I was holding it tight and putting pressure on the screwdriver. And it just literally ripped the inside of the heads out. So that's the only problem. There's the 3 sections of scale that I have cut off. And as you can see from the readout here, the scales are working perfectly well. So that was a success. Has it been a good exercise? Yes, it has. I now have a digital readout which gives me flexibility. I can move it around on the arm that I made. It tilts and everything else. The readouts work. I need to work out a way of covering this one, but that will be modifying the shield that came with it. You need to be aware that you will need to either make some brackets or modify the brackets that you get with it. There's bits of the modifications that I've done, where offcuts, holes have been drilled, bits have been shaven down, but this is a generic kit. It will pretty well do what you want with what you get, but you need to bear in mind you will have to modify stuff almost certainly. Is that an issue? No, not really. And it means that a couple of days interrupted work has given me 3 scales and a readout that will enable me to work more comfortably and more accurately, hopefully, on the mill. As I say, it's an old Tom Senior, not that old because it's a Denford one, and if anyone can tell me what the colour is of the Denford turquoise, I'd be very grateful. But it's made a really good machine even better, and I think that is a good deal. So I hope you found it interesting. I will apologise, it's been a bit bitty. I've had a few camera issues and also been pulled away by the family, as tends to happen. One of the things was to go roller skating yesterday, which I'm still trying to recover from. But I hope you found it interesting. If you want to do this for your mill, good. If you can afford it, go to a supplier in the UK like Allendale's Digital DRO, or Machine DRO rather, who will give you a specific kit. But if you're a bit tight on budget, this will do the job. So if you enjoyed it, please like and subscribe for more content. The more I get, the more I can do. And from the moment, I will wish you goodbye from Dad's Shed.